Hello guys, in this video I will demonstrate how we can onboard Site 102 to our SD-WAN fabric by using bootstrapping method. For your reference, I'm using this hardware and softwares. And here's the topology that I created. It's a straightforward design with a full mesh data plane connectivity. The routing protocol that I choose for service VPN 100 is eBGP facing LAN. The goal is to advertise the loopback 0 to the SD-WAN fabric to test the reachability between the sites. The steps that I'm going to demonstrate is actually not complete. I skipped the part where I synced my account in PNP Connect portal to vManage to download the WAN edge lists and feature template creation. So let's get started. One precheck that you need to perform from the router is actually making sure that it can resolve our VBAN FQD and can reach other controllers. Since all of our controllers are hosted over the internet, we can assume that it can reach the controller since it has internet connectivity. Once you verify that the internet is okay and you can reach the V-band, we can proceed with the bootstrapping. In the vManage, go to the configuration and templates. Under the device templates tab, you can see that I've already created templates for site 255, 100, and 101. What I'm going to do now is copy this template and then make for site 102. Next is you need to attach devices. In this demonstration, I'm using virtual routers, which is the C8000V. So I can choose any of the available chassis and it will not matter. But for the physical routers, you need to select the correct chassis number from the list. Now I'm going to choose the CA8E8 chassis and the 4EA5. So this will be our router 1 and router 2. We continue by populating device-specific values from the feature templates we attach on the device template. Next, configure device, confirm, and then wait for it to complete. The next step would be go to the configuration and then devices. So as you can see, we've already attached the Site 102 template to the chassis numbers. We know that the chassis number that ends with CEA8 will be our CH router 1. So now, what we will going to do is Click the three dots on the right side and then select Generate Bootstrap Configuration. Uncheck the Include Default Root Certificate and then OK. Click Download and then save the file. Transfer this file to our TFTP folder. Since I'm using virtual routers, which is a C8000V, the file name should be correct, which should be like Cisco SD-WAN underscore cloud underscore init. For the physical routers, the file name will be different. It's critical because this is what the router will look on its boot flash when we convert the router into controller mode. For more information about the file names on the Bootstrap configuration, please refer to the Cisco documentation. After doing that, you also need to download the root certificate from your enterprise CA server. For this demonstration, I already have downloaded the root CA certificate. Now that you have downloaded the two files that you need to copy that two files to the router's boot flash. For this demonstration, I'm using my laptop as the TFTP server. Once you copy the root certificate and the CFG file, the next step would be converting the router into controller mode. If you check the show version command, you can see that the router is operating in autonomous mode. So we can convert it to controller mode by issuing a command controller dash mode space enable. So this process will take a while because the router will convert from IOSXE to IOSXE SD-WAN image. And then it will load the bootstrap configuration we saved to the boot flash. So while we're waiting for the router to boot up, we can monitor it from the vManage. Go to the configuration and certificates. So as you can see, the chassis number that we exported is this one, the CAE8. So you can see that the status as of now, or the state, is in Bootstrap configuration generated. So it will take some time. The state of this router will be in CSR logo. As you can see now, the state of the router was changed. It's now CSR generated state. So meaning the router generated CSR that it's ready for signing. Click the three dots on the right side and then select View Device CSR. We need to copy this file and then send it to the CA server for signing. Download the base64 encoded file and then download the certificate. Open it using Notepad and then copy everything. Close this window and then select Install Certificate. Install, and then wait for it to complete. So now we've successfully installed the certificate, signed certificate to the Site 102 Router 1. We can verify if it's successfully onboarded by going to the monitor and then devices. As you can see, the Site 102 Router 1 is should should come up. Let's let's wait for a couple of seconds here. So as you can see, the Site 102 Router 1 has been successfully onboarded. We need to perform the exact same process to onboard the Router 2. Go to Configuration, Devices, and then look for the chassis number that ends with 4EA5. This one. So now, we've successfully onboarded the two routers for the Site 102. Let's go ahead and check if the BGP is now up from Site 102's core switch. As you can see, the eBGP peering between the core switch and the two SD-WAN routers are now up. And we can see that we are receiving 6 prefixes. Let's go ahead and see what we are receiving on the routing table. So, based on our diagram, we should see the loopback interfaces of the site 100, which is this one, site 101, which is this one, and site 100, sorry, site 255, which is this one. So if we can test the reachability, we can ping the site 100 loopback address from our loopback address 0. It's also true for site 102 and site 255. So if we are going to trace route, going to the site 101, we can see that since this is a full mesh connectivity, we can see that the hops are just it's going directly to the site 101. We can also do an ECMP for this setup because right now the primary route going to the other sites are just the router one. But if we go to check the BGP table, we can see that we can establish an ECMP. By doing that, we need to specify maximum paths to two. Now we can see that we have two equal costs to the other sites. Thank you for watching.